today's video, we're upgrading our compressor. If you remember last week's video, we got that old blue reciprocating compressor out there that shot the craps that should have never been in use to begin with. Well, anyway, I got a steal of a deal on some really great equipment. We're upgrading, and it's going to give you a chance to see what you could go to if you can exercise your contacts in your network. So if you're building a smoker shop or you already have a big smoker shop and you want to upgrade your air, watch this video. Hey guys, I'm Frank Cox. I'm known as the Barbecue Pit Engineer, and this is the Smokerbuilder YouTube channel. Welcome back. So if you remember the last video we did, I showed you that death trap of a compressor out in the future welding shop. Out in it's unconditioned, it's cold out there and all that stuff. Well, anyway, we're here in the hallway, what we call it, and this is the gap between our nice heated air-conditioned shop on the other side of this wall and the downstairs, which is where welding shop is going. So this is kind of where we do shipping and receiving. It looks like a wreck, but this is the best place for this compressor because it's not as cold in here as it is out there. So anyway, this is just the tank, and it's a big old tank, right? So a little bit about this tank. This is a vacuum tank, but it is certified for air use. Came out of a hospital. Go search those salvage yards, find buddies that are in the salvage business, and you can find something like this. I'm not going to tell you what we paid for it, but I'm shocked how affordably we got this tank. 200 gallons of air. Now, what kind of pump are we going to put on this? You're not going to believe it, but I stumbled on a deal from my buddy Jim, who's an air compressor man for a living. And Jim's always been there for me. He's always helped me out with stuff. So let's go in the other room and I'll show you what we got. Okay, guys, so I literally had to pinch myself when I stumbled on this deal from my buddy Jim. So no lie, we were completely down and we got to cut doors on those 1,000-gallon tanks with the plasma cutter. And like compressor, it's not safe to use. You know, I work on that stuff for a living, so I know what's wrong with it, you know. But anyway, my buddy Jim just happened to have exactly the thing that literally for the last 10 years I would go to sleep wishing I could afford or wish I could have. I mean, any of you guys know about Kaeser. This is a Kaeser, I say Kaeser. But this is a Sigma 5, a rotary screw compressor, and it's about 21 CFM. The bonus is I've got 3-phase in this shop. So this thing right here will pull full load amps on the whole unit, 15 amps. So it's super affordable to run, and it's delivering 21 CFM out of this nozzle at dynamic pressure. But also, this thing's smart. It's got a computer on it, and it'll tell me air temperature. It'll tell me how many hours it's been running. It'll give me some data that I can look at to do things with. So running it on 3-phase, it's a lot cheaper to run in an environment like this. And I don't think we're ever going to outgrow this in this shop. So I'm super excited, but what makes it even better, if you go back and watch the last video I put up where I was talking about the blue compressor blues, I'm going to call it, out there with that reciprocating compressor. Reciprocating means it's got pumps that do like this, right? This one's got screws that do like that. See the logo? So what happens is we need to get that air as dry as we possibly can for a few reasons. We want our equipment to last longer. We don't want it to tear up. The second thing is we don't want our tank to rust out from the inside. Now, I was lucky enough, that tank was in vacuum use in a hospital. So I know for a fact it's super dry inside because it was for medical use, the vacuum was. So in this case, we're going to shove air in that compressor, out of this compressor into that tank, but we've got this other cool thing right here. Actually, I got 2 of them. One's for air. But anyway, this is a refrigerated air dryer. That's how we're going to handle this moisture. So this thing literally has a refrigeration system in it, and that's how we dehumidify, is with an air conditioning system's dehumidify. So that's what's going on right here. So we're going to cool that air down before we dump it into that tank. This thing's going to extract the moisture or the water vapor out of the air, and it's going to put it in a safe place. So we may not be 100% dry, but we will be much, much, much drier than we could ever be just out there in that old cold welding shop or just this air in this room, right? So anyway, that's a few things we're going to do. So the rest of this video is just going to be me popping in once in a while and just showing you kind of where we're at. We got a long day ahead of us, so I can't fool around on the camera too long. But now I got to get that tank off the dollies and on the ground. Then we got to build a frame to support these, to keep these from walking off of the top of that and this compressor will be on one side and the dryer will be on the other side of that air, main air going into the tank. So anyway, I appreciate you guys. Just enjoy the video and let me know in the comments if you got any questions, and we'll check in here in a little while. Okay, guys, it's been a couple of weeks. We've had these compressors in service now for quite some time. Let me kind of go over what all we did. I'm going to flip the camera around here so I can kind of point and talk. I wasn't able to actually set up a tripod and video all of this just because I honestly it would have been hours and hours and hours and hours of video. But I have everything in such a fashion that I can show you what I did, and then I can actually let you watch this thing run for a minute. Anyway, it's really, really, really tons better than I thought it would be. So here we go. Okay, guys, you can see we got this thing up off of the stands there. We put it on the ground, this 200-gallon tank. We did put some rubber matting underneath because it's going to have some vibration and stuff like that. That's going to make a lot of noise here. And I just wanted to take care of that. I did not anchor it down to the ground just because I don't expect this thing's going to move very much. It doesn't vibrate like a reciprocating compressor does. Anyway, we got a nice big air drain right there. Just to get all the moisture out of it, you just open that nozzle. It's going to blow air out, and moisture will come out of there. It's been super dry. I've done it like 6 or 7 times. I've never seen moisture come out yet. And we're leaning on this compressor big time. It runs a lot more than I thought it would. Right now, we've got it hooked up to 3-phase here. I'll show you kind of some of that. It's on, and it's just sitting here in go mode. Now, when we did the setup on this, see if I can remember, when you push down on here, let's see which one's which here. Let's see, right there. Okay, so, okay, we've got it set for 110 PSI, which is what Jim told me to set it for. And then we've got a 20 PSI differential, which is the cutout. So that basically means that it's going to satisfy at 110 PSI. And whenever that gets down to 90 PSI, it comes on. What's really cool about this unit here is that whenever it comes on, it's modulating. So I can't open it up right now, but inside of there is a modulation valve. You'll see the screws right here, and then that modulating valve has a diaphragm in it that opens and shuts. What that does is that it runs full column of air based on demand, which is really crazy. So we don't want to speed up and slow down the screws in this thing. Rather, we want to speed up and slow down the volume of air that can go out of that modulating valve into the tank. And you can set that. There's all kinds of parameters on how to set that in the manual. By the way, one major downside to Kaeser, you know, when I was working on food equipment, Hobart was always the one that was the hardest one to get manuals for, hardest one to get parts for. Pretty much everybody paid retail. Contractors didn't get any wholesale discounts unless they were certified or authorized Hobart. That's kind of how this is. It's kind of like locked down. So I found out, like, even with my refrigeration background and being a service company and all of that, they would actually not sell me parts because I'm a contractor. They would only sell parts direct to consumer, or you had to call your authorized service center for Kaeser, however it is. And anyway, so that part of it is a huge downside. I think I'm still really happy with this. I can't go wrong with where I'm at. These things are awesome. And I know people that can get parts and stuff like that for me if I need them. However, if you're not like comfortable in that scenario, you might look at another brand. There's another one out there called Quincy. I know you can get a lot of that stuff just at Granger, stuff like that. There's a million other kind of brands out there, but as far as like the performance of this machine, though, in my opinion, it is better than anything I could have ever hoped for. Anyway, that modulating valve. So here's what happens. The compressor will kick on, and it kicks on unloaded, which basically means that it's going to start the motor running. It's a split winding start, which means it starts half the motor and then it kicks up and starts the rest of the motor. And that happens over like a very short, just couple of seconds. And it's like soft starting. It's really affordable on utility usage and stuff like that. And it really helps out your motor to just not just get wore out and burnt up. So the other side of that coin is that whenever this thing starts up, it starts unloaded. And that basically means that it's not compressing air when it starts
for the first so many seconds, and then it starts to load up. And you can actually hear that, that's that modulating valve. You can actually hear that compressor, it snaps like a relay closes and then it loads up, and then we start pumping air. Now, this thing's capable of 21 CFM or SCFM. And so that's how you measure airline air coming out of a pipe, right? So this thing's capable of 21 SCFM, but if the demand doesn't require it, say that you're just airing up a tire and we got down to 94, it's going to look at how fast it's making up from that demand. Whereas if you're trying, this isn't quite big enough for a big sandblaster or nothing, but if you're trying to run this thing like to sandblast or something like that, it's going to see that there's more of a constant demand. And so that modulating valve will start to throttle up and open, and it'll let this thing flow at full capacity in order to keep your storage tank at pressure or closer to pressure. So I think I don't know for sure the logic there, but I think it's measuring that based on the pressure drop and how fast the compressor is running. So anyway, go over the piping here a little bit, and I'll show you just kind of how I piped this up and some of the safety things you got to keep in mind. So originally, this line right here is what was feeding into the system from the compressor that's outside. And what I did is I literally just took a Sawzall and cut this right here. Of course, the air line was completely depressurized. Make sure that you never work on anything that's got pressure in it. But anyway, the whole system was shut down anyway. I had the compressor completely unhooked. The power was disconnected, so nothing could happen. And then I took this line and cut it with a Sawzall. And then this line was going straight down to there, which goes through the other side of the wall. Basically what I did is I just put a 45 on that and made this, I just anchored that line right there. And then you just take you can get a powered hand threader from Harbor Freight, really super cheap, that comes with a vise that chucks down to the line. And then you can thread this. That's how I threaded that pipe. Then I got a big pipe threader stand over there that I use for everything else. But you always need a union everywhere you can if you're going to have to build back. So in other words, if this joint was leaking, I wouldn't have to go all the way to the compressor and unpipe everything all the way back just to tighten this nipple. So anyway, what I did is I put a union in here, and then we've got a T, and then I've got another cap up here on top in case I ever want to take off from that and run somewhere else, which I do have future plans for things. Or if I needed some other device somewhere in the building, I could come off of that. Anyway, that goes down. This is flowing out of the compressor tank. All of this is, and that goes to that line there. You can see us going back. Anyway, so air comes out of this compressor in the back, and then it comes out of this line right here, and it has to go into the back of this dryer. For the dryer to work, it has to go in a certain direction. It goes in, there's a bunch of filters in process here, including a heat exchanger. Then it comes out of that dryer and goes into the tank down low. Now, something important that I didn't realize is that you want your air to go in down low and come out of the tank up high. It makes complete sense to me now that I heard it. Jim actually told me that. So our air comes out of the dryer and it goes all the way down and goes in down low. That way moisture, and just in case any kind of sediment or anything's in the air coming out, which it wouldn't be in this system, but it would fall down to the bottom. Any oil, sometimes oil comes out even with this system. And then we pressurize this 200-gallon tank. Now you come out of the top in the middle and on this tank, and the important thing to know, this is something that if you're installing any kind of a compressor of any kind for yourself, you want to make sure that there's no valve between this pressure relief and the vessel or the tank, the storage tank. Because if somebody was to close that valve off, now the pressure relief can't do its job and this tank could rupture. So you really want to make sure that you got things piped right, just like a water heater or anything else. That pressure relief is here to protect the system in case of an overpressurized state. And that means that basically we got to have that on the tank, which is where between the valve and the device that's providing the air pressure. So anyway, it's filling up this tank. That's the easiest place to grab it from. Here we got that pressure relief, and that pressure relief must be sized according to the operating pressure and the CFM. So anyway, Jim knows more than I do about this stuff. He helped me get the right pressure relief. I don't know if you can see any of those numbers on there. That's kind of what we're running at. We're only running 100 and something PSI, but this vessel is certified for 200 PSI. So I think that's what the pressure relief has to be rated for. Anyway, we come out, then we got a ball valve here. You can close that. We reduce down to 3/4, and then this line goes out to the rest of the building. Let me turn this camera around. We'll talk some more. So what I'm going to do now is I'd like to show you how this thing runs, just kind of a sequence on it, just give you an idea, you know, how much quieter one of these systems is. Now, I'm operating on whatever the microphone on the camera is here. I don't have any fancy camera equipment. Could be my AirPods, could be this thing. I don't know. But anyway, to me, I can have a conversation in this room and not even think about this compressor running. It's not loud. It doesn't vibrate real loud or anything like that. And to do that, I'm just going to bleed some air off right here. We're sitting around 94 PSI. This is probably going to be a little bit loud. It's got to bleed down for a little bit, and then I'll close it once we get close to 90. So you can see the pressure fall. Just going to trickle it a little bit. See what we're doing here. We're at 93 right now. The other thing that's really good to know about this system is that you can see your crankcase pressure or temperature, your oil temperatures and stuff, just to see how hot this unit's getting. In other words, if this thing's just running, it's not letting that oil overheat in the system. We're down to 91 PSI. See what happens. Here we go. We got a good conversation happening. Not very loud. It's awesome. There, it just loaded up. Now I'm going to flip the camera around so you can watch the dial. Man, that thing ain't even loud at all. You can sit in the other room and have an actual conversation. I love it so much. So you can see we're starting to pressurize. Where's my finger? Right there. 100 PSI. And oil temperature, about 84 degrees. Our target is 110. This thing right here shows you how loaded the compressor is. That arrow will go up and down based on demand. And then what's going to happen is once we get closer to 109 PSI, I think is where it's going to do it. You're going to hear this thing shift, and you're going to see this arrow unload. You'll still see the arrow, but it'll be empty. And that basically means that we're unloaded. And it's going to continue to run for like, I don't know, 15 minutes or something, just in case there's a drop. So here we go, we just hit. There's that modulation valve just squeaked. And now you can see it's unloaded. So now it's just going to sit here and run for 15 minutes. That way it doesn't have to restart in the event that I ran the plasma cutter again. Stuff like that. Pretty cool, huh? So anyway, guys, that's a little tour of my Kaeser Sigma 5 air compressor and just how we set everything up. Of course, you know, like I said, I don't have the dryer running right now. The dryer would be a lot louder. Honestly, I don't even really feel like I need that dryer. In situations where I'm painting and stuff like that, maybe it would be helpful to have that. But it's just kind of interesting just to see how much different just moving the compressor situation from out in that unconditioned cold shop, moving that compressor up here and having a different style of compressor as well, because there's a bunch of filters inside of here too in line that just kind of help keep the dust out of the air. I've noticed a complete change in the way that our shop runs. Anyway, you can probably hear it running back there a little bit, but it's not very loud at all where I'm standing. Anyway, guys, till next time, keep your smoke thin and blue. And by the way, I've got a whole bunch of online courses I'm launching over in smokerbuilderu.com. Head on over there and participate in the fun. Learn how to build a smoker, maybe even start your own smoker shop. So anyway, appreciate you. Have a great time. We'll see you later.